Today, my group will present for assignment BEEZ1213 instrument and measurement. So, for the first is group members is Muhammad Syazni Fikri bin Suhaimi. Second, Ahmad Afiq bin Muhammad Asnizam. And third, for Muhammad Firdaus bin Jafri. For our instructor is Puan Nur Alisa dan Encik Fakrullah. So the first one is multimeter, second oscilloscope, and third is sensor technology. So for the first one is I will pass to the Firdaus.
Okay, today I will explain about multimeter. Multimeter is a measurement device that can assess several electrical characteristics. Some include the measurement of other characteristics like capacitance and temperature. An amplified analog multimeter combines a meter movement, range resistor, and switch. With EMS, amplified analog meter and contain electric circuitry. The inventor Donald McKenzie created the first voltmeter after growing frustrated with having to carry so many different tools for maintenance telecommunication network. The meter comprises a moving coil meter, voltage and phase resistor, and switch and sockets. It measures ampere, volts, and ohm. In the 1920s, meter resembling pocket watch were frequently used. It was customary to attach the metal case to the negative connection, which result in countless electric shocks. This device technical specifications were frequently rudimentary. For instance, the one shown has resistance of only 25 volt, a non-linear scale, and no zero adjustment of either range. Analog, and this is the analog and digital multimeter. The left one is the advantage of multimeter. High accuracy, high input impedance, so there is no effect of rolling. A clear reading at higher viewing distance can be obtained. The electrical output can be used to interface with additional equipment. These are less costly to the integrated technology. The price of multimeter is around 40 ringgit to 200 ringgit. DC emitter. The Earth magnetic field was necessary for the operation of the earliest emitter, which were laboratory instruments. Improved instruments were created by the late 19th century that could be put in any orientation and permit precise measurements in electric power system. In a circuit, it is typically symbolized by the letter A. Hans Christian Ørsted made the first observation of the relationship between electric current, magnetic fields, and physical force in 1820, when he noticed a compass needle was pivoted from pointing north while a current flowed through a neighboring wire. This effect was employed to measure currents using a tangent galvanometer, where the Earth's magnetic field served as the restoring force that brought the pointing back to zero. Around 1914, Sir Charles Houston used the name rheoscope to refer to an electrical current detector. The work makeup has a connection to the restart, a device used to regulate the current in a circuit, and also Houston's invention. Contrary to rheoscope, the term rheostat from the past refers to a changing resistance. Current is the rate of flow of electric charge. If this electric charge flows only in one direction, then the resultant current is called direct current, DC. The instrument which is used to measure the direct current called DC emitter. The permanent magnet moving coil PMMC galvanometer can be used in conjunction with a resistor to create a DC emitter. Shunt resistance or simply shunt is another name for the parallel resistance used in DC emitter. To measure the huge DC current, the value of this resistance should be regarded as small. Analog and digital DC emitter. The left one is analog DC emitter and the right one is digital DC emitter. Advantage of DC emitter. It is strong and portable. It does not depend on the Earth's magnetic field. It can make very accurate. An emitter is used to measure the magnitude of electric current in an electric circuit. Some emitter has no hysteresis error. The price of DC emitter is around 190 to 450. AC voltmeter. A voltmeter is an instrument used for measuring electric potential difference between 2 points in an electric circuit. It was first developed in the early 1880 when growth of electric lightning demanded such an instrument. The demand for voltmeter rose dramatically in the late 19th century. Edward Weston developed his Model 1 voltmeter in 1880, and it became the first product of the Western Electrical Instrument Company. The Model 1 became the standard variant in electrical meters, as did another of Western's invention, the standard cell. A voltmeter is placed in parallel with a circuit element to measure the voltage drop across it and must be designed to draw a very little current from the circuit so that it does not appreciably change the circuit it is measuring. This is analog and digital DC voltmeter. The left one is analog DC voltmeter and the right one is digital DC voltmeter. Advantage of DC voltmeter. Readings are accurate and fast compared to voltmeter. Digital voltmeter is more stable and reliable, smaller in size and cost effective. PVM can measure both AC and DC voltage of the electrical appliances. Price of DC voltmeter is around 190 to 450.
Okay, the second part is technology of oscilloscope. Okay. Okay, history. In the second decade of 19th century, waveform were first captured using galvanometer, connected to a mechanical drawing device. Then, in the modern day, the digital oscilloscope is the result of multiple previous invention, which is hand-drawn oscillogram, automatic paper-drawn oscillograph, photographic oscillograph, tilting mirror, cathode ray tube (CRT), sweep circuit, electronic, and digital oscilloscope. Yes, this diagram for the how the operational of oscilloscope. Okay, that's okay. For the operation, first the input signal amplified in the vertical trigger, then the output of the vertical trigger provides some amount of delay to the signal. In the trigger circuit, the signal is triggered to the synchronized both horizontal and vertical deflection of the beam. In the time-based generator, it produces a sawtooth signal. The power signal produces high and low voltage. The negative high voltage and low positive voltage are applied to cathode ray tube and the other circuit. In the CRT, there are mainly four parts, which is electron gun, vertical deflection plate, horizontal deflection plate, and fluorescent screen. Okay, in the CRT, the electron gun produces electron beam to get the deflect in the horizontal and vertical direction by pair of horizontal and vertical deflection plate. Finally, the deflection beam will appear on the fluorescent screen. Okay, that's okay. This is the latest technology of the oscilloscope, which is range in medium 4000 Hz. Scope channel is 4 plus 16 channel. Bandwidth 1 gigahertz. Sampling rate 5 giga SPS. Display memory depth 4 MPST. Calculated rise time 450 ps. Scope display type VGA touchscreen LCD color, which is price 141,848 ringgit and 20 cents. Okay, all for the part B. So I will pass to Shazadi.
So now is the technology of sensor. So for requirement for C is to choose two sensor of all transducer. So I'm choose magnetic sensor and piezoelectric transducer. Magnetic sensor is to measure the displacement and the output is the form of change in inductance. Meanwhile, piezoelectric transducer measure the pressure, acceleration, and force. So the first one, magnetic sensor can gauge speed of up to 6 million km per hour. These are used to measure the geomagnetism produced by an electric current or magnet. The sensor output is used to track the presence of electric current as well as its direction, location, and angle. Operation principle is to explain how a magnetic sensor function. Think about the coil magnetic sensor. In a variety of magnetic sensor applications, coils such as flux gauge sensor, charge coil, resolver, rotation sensor, and angle sensor are employed. Even though coil itself cannot directly measure magnetic field. It may identify alteration or oscillation in the magnetic field. The coil magnetic flux density will rise when the magnet is positioned closer to it as a result of an induced current and electromotive force (EMF). Application of magnetic sensor. First one is automobile and automotive, robotic and factory automation. Third, military, biomedical application, geophysics application, industrial measurement, space equipment, consumer electronic, agriculture, power supply unit, water and energy appliance, green energy power plant. Next is for piezoelectric transducer. Piezoelectric transducer is a device that measures change in acceleration, pressure, strain, temperature, and or force. The transducer transforms this energy into voltage when we secure or exert any pressure or force on them. This voltage changes according to amount of pressure or force applied to it. The electric voltage produced by a piezoelectric transducer can be easily measured, since this voltage will be a function of the force or the pressure applied to it. We can infer what the force or pressure was by the voltage reading taken from its insulator. Operation principle. Piezoelectric transducer work with the principle of piezoelectricity. The phase of piezoelectric material, usually quartz, is coated with a thin layer of conductor material such as silver. When the stress has applied, the ion in the material move toward one of the conductive surface while moving away from the others. This result is in the direction of charge. This charge is used for calculations of stress. The polarity of the produced charge depends upon the direction of the applied stress. Stress can be applied in two forms, as compressive stress and tensile stress, as shown below. For parametric equation of piezoelectric transducer, the orientation of crystal also affects the amount of voltage generated. Crystal in a transducer can be arranged in a longitudinal position or transverse position. The way a piezoelectric material is cut define one is three main operation modes. First one, transverse. Second, longitudinal, and third, shear. Transverse is a force applied along a neutral axis y, displaced just along the x direction, perpendicular to the line of force. The amount of charge Qx depends on the geometrical dimension of the respective piezoelectric element. When dimension is A, B, and D, apply. This is an equation for transverse. When A is a dimension in the line with the natural axis, B is in line with the charge generating axis, and D is the corresponding piezoelectric coefficient. Longitudinal, the amount of charge displaced is strictly proportional to the applied force, and it dependent of the piezoelectric element size and shape. Putting several elements mechanically is in series and electrically in parallel is the only way to increase charge output. The result charge is this equation: Qx equal to dxx multiply fx multiply with n. The third one is here. The change produced is exactly proportional to the applied force and is generated at a right angle to the force. The charge is independent of the element of size and shape. For an element mechanically in series and electrically in parallel, the charge is this equation: Qx equal to 2dxx multiplied by fx and multiplied by n. Lastly, piezoelectric transducer application. As piezoelectric material cannot measure static value, these are primarily used for measuring surface roughness in an accelerometer and as a vibration pickup. They are used in seismograph to measure vibration in rocket, in strain gauge to measure force, stress, and vibration. Used by automotive industry to measure detonation in engine. These are used in ultrasonic imaging in medical application. That's all for our group.